Hello, everyone. Welcome to Catalog and Cocktails. It's your honest, no BS, non-salesy conversation about enterprise data management presented by Data.World. I'm Tim Gasper, longtime product guy, customer guy, and data nerd at Data.World, joined by Juan.
Hey, everybody. I'm Juan Cicada, principal scientist at Data.World. And as always, a pleasure. And middle of the week, end of the day, and that time to go just take a break and chat about data. And today we're going to be talking about a topic that I always wonder, why don't we talk more about it? Because I always believe it's everywhere, but it's something that we don't talk about it. And I think we have the best person probably on earth to be able to talk about this. I'm so excited to have Jeff Jonas here. He's a CEO of Senzing. He's a former IBM fellow, which I think was one of the most amazing things that can happen at IBM, and a renowned expert on entity resolution. Jeff, it is a pleasure and honor to have you as a guest here at Catalog and Cocktails. How are you doing?
Hey, I'm great. I'm sitting in Brooklyn. Weather's good.
All right. Well, I'm still here in Playa del Carmen. So if things are loud, it's just because this is how life is over here. Tim, where are you, Tim?
I am at the Lost Pines Resort, Hyatt, a little bit off east of Austin, where we just had our executive offsite. It's very nice out here. Some pleasant trails and things like that. A little muddy, though, but enjoying the Austin weather today.
Awesome. So, all right, we got our tell and toast. So let's kick it off. What are we drinking and what are we toasting for today? Jeff, kick it off.
Well, I am drinking a mocktail because it's kind of still in the middle of my work day. It's a grapefruit-oriented sparkling water. I do have it in a fancy glass with some cubes. And I would be toasting to the beauty of adding more data to getting better answers and better decisions.
Well, I'm going to toast for we need to have less garbage in. We need to eliminate the garbage in, garbage out thing. So I think this is all about let's really start understanding the value, the knowledge around the data. Make sure that we have really beautiful data to make better decisions with. I'm having a pina colada today. Actually, I don't think I've ever had this cocktail here during the show. How about you, Tim? What are you up to?
It's pretty good. I've got some vodka and Sprite over here, so keeping it very, very simple. But enjoying the libations as well. So, what should we cheers to?
Data, more data, good.
Very much more good quality data. That's for sure we need.
Well, Juan, I want to comment on that. Oh, wait, we're going to do cheers now. Okay, cheers. Juan, what if I said to you that errors and natural variability in the data actually made systems smarter? And let me give you an example of this, okay? When you search Google and it says, did you mean this? It's not looking in a dictionary. It's remembered people's errors. Similarly, in my space, natural variability, misspellings. My brother's name's Rhodey, but some people don't know how to spell that. They haven't seen it, so they misspell it. It turns out those errors in the data later can become your friend. Bad data, good. Huh?
So I think those, one thing is, I think they're observations of what's occurring in the world. And then they can be interpreted in different ways, and they can be interpreted as an error. But then at the end of the day, it's just, this is what actually happened. And then we want to learn from those things. So I think we learn from what others can consider errors. So I think that is a very good, accurate point, that there's a lot to be learned from errors.
And by the way, I see the world as filled with observations. What we observe as humans and what systems observe, what they collect in their eyeballs, so to speak, is observations. By the way, another example of bad data good is I have a son that has 2 dates of birth. It's a bad daddy, very embarrassing story. Okay, but I'm gonna tell you really fast. I know I'm forcing it on you. You even started the thing. Okay, get this. My kid's born on September 2nd. Okay, but I in my head get it wrong. I convinced the grandparents, the mom, everybody that it's September 5th. We celebrate this kid's birthday on September 5th for years. Okay. Now he's like 5 or 6. I get his birth certificate so I can take him to Mexico. And to my surprise, his birthday's wrong. First, how do you sell it to your kid? You teach them their birthday, and now you're like, I got it wrong your whole life. But imagine if you put the same birthday in a bunch of systems, healthcare systems, Ricky Rick magazine, or whatever, and 5 years later, you see one bad date of birth. How does ever dissent fester and become dominant? If every system in its right mind cleaned out the one, because there was 200 pieces of evidence about September 5th. So it turns out this is another case where bad data can be your friend because you have to let it fester. Okay, fine. Enough about bad data.
Oh no, we got more of this to go. But all right. Well, actually, this is a great segue into our warm-up question, which is, what is something you thought to be true in life that ended up being false? I just realized that maybe you could only have one birthday, but apparently, yeah, you can have two.
Plenty of cases actually where bad data can be your friend. But I mean, you want me to really take a shot at that, or should we just?
Yeah, please. I think you have something profound to say on this.
I would have thought in my maybe early 20s that, you know, you get married and you just stay married and you be married. But now that I have 3 ex-wives, oh, and I'm a good ex. Now to me, relation to the thing I've been convinced out of is relationships are arcs, you know, and they have beginnings and middles and ends, and you do them as long as everybody's winning.
I think that's very deep.
This is the data story. The data story is I have a lot of data on that. Okay, with my ex-wives. What'd you say?
How about you, Tim? What's yours?
Yeah, what were you gonna say, Tim?
I was just saying. I think that's deep. You know, relationships are an investment, and they're also, you know, they go in all sorts of different directions. You know what? I always think that words mean certain things, and then I find out later that they mean something different. I'm terrible with the purity of semantics and what they mean, and so I know that's kind of a generic thing. I can't think of a specific word because I probably don't have it at the tip of my tongue. It's part of the problem, but I mess up words all the time. So that's stuff that I think is true and ends up being false.
Words matter. But all right, let's dive in here. So, Jeff, honest, no BS. If entity resolution is everywhere, why don't we apparently realize it?
Well, I don't know, man. I struggle with this. Like, why? How come it's so buried? For part of the reason I think is it has so many names. It comes in so many forms. Some people heard of like match merge in marketing, or database marketing list append, where you're adding some new fields. You know, you have to match it to something. Link detection, fuzzy record matching. Oh man, there's a lot. Patient record matching. There's like 50 terms for it, but it sits underneath, and it's the bane of analytics because is it really 3 people or 1? Like, how good can analytics be if you can't count? That's the entity resolution is really counting your entities, you know? Is it how many customers do we really have? By the way, you have duplicates in your phone? You know, I bet you have a few dupes in your phone, huh? That's an entity resolution problem. But that's crazy, man, because you're the only curator. Imagine that. You're the only curator. There's dupes in your phone. Imagine if you're a bank, an insurance company, social service agency. They have all of these people entering stuff. Man, you think you got dupes. It's everywhere.
This is a fascinating definition. Entity resolution is really just about counting your entities.
Yeah.
Knowing how many entities you have. I think that's a very clean, crisp definition right there that we need to be able to understand. So it's like not just linking things together, but also like deduplication and so forth around that. And there's so many different names. I mean, even if you go to the Wikipedia article about entity resolution, it's like, and all these different names that this thing has, right? So that's definitely one of the things. But if we look at the tech stacks, all the modern data stacks, everything out there, there's the databases, right? There's the analytics and all these, but there isn't the tool that people are buying for entity resolution. Like, why is that the case?
It's some ETL flows, you know. Most people are trying to build it themselves, but they don't. It's not obvious to folks that you could spend $20 million in 5 years and have something that's still not very good and not very competitive and definitely not agile, and it doesn't let you to pivot into new markets. And then you add some new data source and get some new features. And now you got a Twitter handle and you got an IP address and this and that. And now you have to go back to your data scientists, and they're like, they study the dark art of entity resolution, and they will work for you the rest of their lives. That's kind of like the State of the Union. But the headline is, if you can't count, you can't estimate and predict. Whether you're trying to do marketing or risk score, whether you're trying to figure out whether you should sell them something or shoot them with a laser from space, man, if you can't count your entities, you miss the obvious.
Right.
Resources.
You know, I think that's a great way to kind of simplify things. And, you know, to riff, Juan, off of what you were saying, people talk about a lot of different concepts when they think about this area of entity resolution, right? Record matching, link detection, fuzzy matching, deduplication. Do you see those things as all kind of being within the umbrella of entity resolution? Do you see them as being different? How do you think about all these different terms and how they all relate?
It's all the same thing. Whether you're finding duplicates in a single data source, call that a vertical dupe, or you're trying to combine it with secondary data to get matches across there because you're learning new columns, or is it how many records in this system are in the same in that system? You're all just trying to figure out how many unique entities. And another way to view this is, every pile of data in an organization is just like a different pile of puzzle pieces. Like the blue puzzle pieces over there, it's in the CRM, and the red puzzle pieces are over there because you've done some investigations, and then the gold puzzle pieces over there are your high rollers, and the blah blah blah. And the question is, can you figure out how they all relate to each other? And if you can't see that, these people building machine learning models on data that's not been properly resolved. I'm telling you, these models that don't know, they think you have 3 customers when it's 1. Hey, crazy funny story. I know somebody that wasn't my stuff, okay, because, well, that would be bad. But they had some bad entity matching, and they put somebody on the quarantine COVID bus. But it was a bad match because they're supposed to be on the green bus, not the red bus. You know what? After 5 minutes, they were on the right bus because they were exposed. They have to leave them on there. They spent 2 weeks in quarantine.
Ouch.
Well,
that's a bad mistake.
All right, so let's go into the technical side, because I think for one perspective, actually, it was a conversation we had last week with Malcolm Hawker, who actually called you out as the next guest. I'm like, hey, guess what? He's actually yeah. Great. So let's talk about kind of the history. And we're looking at MDM, master data management, as kind of like the traditional, I always call it the old school approach of just managing all your records and creating that quote unquote single version of the truth type of approach. Like, where are we right now in technology? Let's talk about technology. How have we been doing this today? What is the limits of the technology that we are today? And like, what are we hoping for? What is missing? And how are those gaps being filled?
Well, I'll say the long arc of time, since I've been building entity resolution systems since I was like 22 years old, and then built 5 different generations, and then sold 5th gen to IBM, and then had a vision on how to build another engine. As a general state of the union is, it's very expensive. It's complicated. The results are pretty iffy. It's very hard to do yourself. And some of the evidence of this, by the way, is there has been $750 million in venture capital or growth funding in the last 5 years for entity resolution centric companies. I know single companies that have raised $250 million each. I know 2, $250 million each that have very strong entity resolution. That's expensive. And then you can go on with other list of names, but there's an enormous amount of money that's been going into it. But the State of the Union is, for the most part, it's very expensive, very long projects, and it's hard to get a lot of joy out of it. And my purpose in life has become, it wasn't this a while back, but it has become this, is like, can we not just commoditize it so it's available for everybody? To get the good stuff, man, if you don't have at least $1 million, I heard about a project. I just heard today that somebody said they got their false positives out of their banking system, but the project was 9 digits. That's $100 million or more.
That's an incredible level of investment, and that kind of makes me wonder. People talk about, like, for example, master data management, right? And I know that you can invest in a master data management software tool set for quite a bit cheaper than 9 digits, right? Yeah. But it seems like that some of these projects are at a very different scale. Is that true? Like, some of these, like, really massive and challenging entity resolution problems, are they a very different class of problem than master data management type solutions, or are they actually, is it a slider, a gradient?
When you get to systems that have 1 billion records, 1 billion identities, name, address, phone, that's a record, not counting all the names and all the addresses and all the phones. Like each identity is a record. When you get into billions or tens of billions of records, how to make those systems scale and stay accurate, how to make them real time so you don't have to do a batch reload. How'd you like that? You have 10 billion records loaded. You don't want to load 10 new records. You're like, well, just reboil the ocean. Well, that is not green. So it's, as you get to larger scales and you can't all do it in memory, your techniques have to change. But what the history has been is it's been pretty expensive, million basically minimum to get into really decent entity resolution. You can easily spend 5, 10 million or more. And the question is, what about everybody else? And so part of what I've been trying to do is create something that the smallest little nonprofits can use for chump change and still have the, not just the elite. It's not just for the elite. It's like anybody can do it.
So this is an interesting point that entity resolution is for the elite. So either you have to invest, to get it right, you have to invest a lot of money, as we're talking here. Otherwise, you just kind of don't do it, or you do a crappy job about that.
Yeah. Yeah. And it is if you want to buy entity resolution, is for the elite. And if you want to work on it yourself, I mean, I know organizations with 50 people, 100 people. I know some organizations with hundreds of people that are working on entity resolution. It is that hard. It's crazy.
I mean, from a basic perspective, you see people, I don't know, doing stuff in SQL and doing some fuzzy match. I mean, that's basic stuff, and maybe that gets in somewhere. And if you're a small organization, you only got 50 people, you still got customers. Like, maybe that's the best you can do because you can't afford. It's not. It's a problem, but not a big enough problem that's going to warrant more investment on that. But then it seems that at some point, like that, the stuff that you can do yourself just breaks, and then there's like this gap. There's like either you just kind of live in this really bad world until you really need to invest a shit ton of money to go do this correctly. Like there's this big gap right there. I mean, that's how I've been seeing it, because I've been talking about
yeah, that's true. Like if you want to get something that's 70% competitive and accurate, you could do that for $1 million. You want it to be like 80% towards like a highly competitive product, you might spend $5 million. You want to get like 90%. It's not quite world class, it's not quite bleeding, but you want to get to 90%. You spend $30 million, like literally. It's crazy. But what's going to happen? It's going to get harder and harder for organizations to compete without higher quality entity resolution. Between the false positives and the false negatives, where you're tapping on the wrong shoulder, or looking stupid to your customers. I show up at a hotel. I go to check in. Hey, you even have your loyalty club. So I tell them my name. They go, which one of these is you? They name 3 people. They're all me. Like I have 3. I'm in their club 3 times, and they can't even fix it. It's crazy.
You're not making a good vision, kind of a pretty picture of the world. I mean, you're kind of saying that we're screwed.
Well, the truth is that a lot of decisions are being made, and there's a lot of waste and a lot of bad decisions being made because people aren't counting their entities right. And it deserves some They should either be investing in it, buy or build. But why would anybody, do you think there's anybody out there that still is building their own spell check, grammar checker? I mean, they got their data scientists and they are fascinated with the art of doing grammar and spell checking themselves. Or do you think they're just using a library? Right? That's what I'm trying to do, is like, are you kidding me?
That's a great analogy right there. But are we at the point?
Go ahead, Juan. Yeah.
Are we at the point of commoditizing entity resolution that can be the equivalent of a spell checker that you just called?
Yeah, that's what we're doing. Yeah.
But again, so what has been the missing piece? Like, what are the principles that should be able to apply over and over again? Otherwise, it seems like everything's just going to be a particular project for every single scenario that is not scalable to kind of replicate.
Well, I don't know. I built 5 different generations, and I sold the 5th gen, and then started the 6th gen. But when I told NBN when I was going to build it for them, I was like, $50 million to build it. They're like, $50 million. I go, well, yeah. If I'm going to build a 6th generation, it's going to cost $50 million. Anyway, because it's that hard. But I don't know. You've got to see a lot of use cases to figure out how to build something that's generalized. Okay, because it's real easy to really get really narrow around a certain kind of entity with a certain set of features and study just that. But it took decades and a lot of different use cases to think about it, not in the particular. I did a blog post called this has a little bit to do with it. I did a blog post a long time ago called Hell with Rules. Okay. in the entity resolution space, a lot of times like, okay, if the names are this close, that's this score. And if the addresses are this close, it's this score. And then they're like, what about phone numbers and Twitter handles and Telegram handles and blah, 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 blah. Oh, well, if this and that are true and this and that are true, and you get these growing like combinatorial lists of if these things are true and those things are false at what. The amount of details and rules that you get just grows and grows and grows. I went and met with this lady at a financial company. She goes, hey, I just want to impress you. You know, you didn't know, I know who you are. You know what? We have 10,000 rules. I thought to myself, 10,000 rules. She's bragging to me about 10,000 rules. And so to trivialize all of this, it took me a few months to come back at her with the difference between rules and principles. And so under Senzing, we built a principle-based system, but it basically goes like this. Your kid's throwing rocks at cars. You're like, hey, don't throw rocks at cars. But the next day they're throwing like, you know, sticks at buses or rocks at buses. You're like, okay, don't throw rocks and sticks at buses. The next day they're throwing them at SUVs. Your kid's 35-year-old throwing iPads at Segways. How many rules do you need? If you can't like get a principle going, you know?
Is that
like,
part of the magic here? Is think of it from a principle standpoint? Is that some of the and how do you even do that? Like, is that applying it's more of a semantic understanding?
There's two parts. One is principles, and you know, I'll give you an example of a really simple principle. Is if somebody's identifier, like a passport ID, serial social security number, or in a car, VIN number or license plate number, or a router, serial number, IP address. But if an identifier and the name of it is, if the name is pretty close and the identifier is the same, you're probably good to go. Okay, that's a principle. You don't have to name all the identifiers in the world, socials, MAC addresses, Okay, so that's a principle. But then, like Pirates of the Caribbean, #1, where the lady's on the ship and she looks at the captain, and the captain goes, you know, we're gonna make her walk the plank, and she goes, I invoke rules of parlay, and the evil captain goes, actually, those are guidelines. You have to be able to if you don't want AI, because we have a real-time learning thing, but if you don't want it to go crazy, you know, like put some tape on the stop sign so it thinks it says 55, even though it doesn't say 55, it just goes crazy. You have to operate on good guidelines. So we have a principle, simplest one. Hey, if it's an ID number and a name's pretty close, call it good to go. But the guideline would be unless that ID number's oversubscribed, you know, like if you have 50 people that has the same passport, like 123, 123, 123, that one's not any good, okay? So you get to a self-tuning system. The trick in all of this, though, is you've made 1 billion decisions, okay? And now you get record 1,000,001,001. And in record 1,000,001,001, you learned that the passport number of 123, 123 is no good. In that moment, you have to say, now that I learned that, had I known that in the beginning, over the 1 billion records I've seen, should I have made any decisions differently? You know, any smart system should be able to change its mind about the past. True, real-time learning. By the way, you ever do this? You're listening to somebody chat and you go like, I know what they mean. Then they say a few more things. And you go, oh, now I know what they meant. That. You have to build, if you want to do real-time streaming learning systems like what we're doing in any resolution, that means every record you get, now that I learned this, if I learned something about the past, like, oh, those two people aren't the same. That's a junior, senior. But it wasn't known until this new observation. That's the hard part, by the way. Anyway, I'm blah, blah, blah.
Well, I mean, that's interesting. That's a different frame of mind. And sometimes it's not always a step forward, right? Because you come up with a new principle and you say, oh, wait a second, there's a different way than I should have been thinking about this. But maybe your past heuristic was actually better at being a predictor. Now you've got more work to do before you can get back to where you were. So it seems like it's a hard problem on two fronts at least.
What we are seeing is that I just did a blog post about this recently because it just made me crazy, man. It just made me crazy. They load a small data, what I would call a small data set, and then they want to tinker a little. And I said, no, just keep loading more data, because with more data, because it can change its mind about the past, more data remedies tinkering. By the way, the kinds of tinker you're doing, it might look really good in your small data set with 10 million records. But as you really scale up to your billions of records, those things you're tinkering on, you're not even going to want those later. You know, it's about more data brings, it's just like more evidence points, you know? But it's like, how do you integrate new observations into what you know? It's like a puzzle piece, man. A new puzzle piece shows up and you're trying to figure out where it belongs in the puzzle. Just like when you put a puzzle together at home, sometimes that one piece allows you to realize these two chunks are connected. That's the mental model I have about what's happening inside of I'm going to take it up one level, a context engine. Context meaning understanding something by taking into account the things around it. Like you see the word bat in the sentence, you look at the words around it. That's the way data doesn't sing unless it's in context, okay? It doesn't tell you really what it is unless you can find the related pieces. And entity resolution is the first form of that.
Oh man, this episode has so many awesome quotes. Data doesn't sing unless it's in context.
I just made that up, by the way. Should I drop a little TM on there?
Yeah, I mean, I will be quoting you on this one. I mean, we're gonna get a bunch of T-shirts out with like quotes like this. That's definitely gonna be on that one. All right, you've got my brain here thinking. So, a couple of things. One is, the lady who said they have 10,000 rules. Okay, how many principles are there? Yeah.
Here's my goal, okay, and it's all imperfect because that's the world we live in. My goal was that I would have the number of principles would fit on a screen, a single screen. You could look at them all at once, okay? Not font size 6, okay? And that the set of principles work, whether it's people data, company data, vessels, planes, routers, cars, same set of principles. It'll work in English, it'll work in Arabic, Cyrillic, Mandarin, no changes. Okay? That was the vision I started out with. And how I did it, by the way, when I thought about this new invention, I'll call it, this new method, is radically different method. By the way, I originally called this project G2, not for Gen 2. Genus is a different species. Like if you looked at my first 5 generations, you can see how it grew up. Huh? You'd be like, oh, look at what he did to the schema. Well, that was nice. He normalized that and made that a type value pair. Cool. You could see it grow up. This new thing, this is radical. What I did though is I made a little list of, I made columns. I said people, I had companies, then cars and routers. Okay. And I made examples of all the features of each, like, people, names and addresses and phone numbers and date of birth, Cars, make, model, VIN, color, So I listed the common features for these. What we've been doing in entity resolution is you think about each domain uniquely. You look up underneath that column and go, what combinations of things with which weights should I drive these things together? And then you look over at cars and go, okay, good. VINs are always pretty good. Make and model, those never change over a lifetime. What I did is I thought about it horizontally. I said, what is it about us as humans and we can do entity resolution in new domains all the time? And I said, what is it about a social that makes it like a VIN? What's a VIN? How does that make it like a MAC address on a router? And it led me to behaviors, just a few behaviors. So you can pick a new entity type and you can just pick new features and you assign the features one of three behaviors and you're done.
Okay. But there has to be a number here, right? What is it?
Like 26. Right now I've got like 26, okay, or 28 principles. By the way, now and then we add another one, okay, or change one. But when we do, it's good for everybody. It's really weird. I can fix it, make it match vessels better for the Singaporean maritime project, and it makes it better for somebody doing corporate supply chain data with, corporate data with corporate hierarchies. Like, that's how I know I'm on the right track, okay?
Let me get a little bit philosophical here because I completely agree with you. This what we're talking right now is, for me, this is a demonstration that why computer science is actually a science, because what we're seeing here is that we're studying, you're observing a phenomena here of computation, of you're saying, if I look at this thing that I go down here, it's always this, I mean, I make VIN, make, model here, name, address, all these things. But then what you observe here is like, oh, there's like a higher level abstraction which applies to all these things. And then after seeing so many times over and over again, you realize, oh, this is not applicable. This thing that I just observed is applicable to cars, to people, to vessels, to routers, and so forth. And I think something that we learn in computer science, or for me, actually, computer science is all about understanding the levels of abstractions. You figure out what level of abstractions you're going to be in, and maybe you also become a compiler. You like to focus, and I want to move between one level of abstraction to another. So for me, everything you're saying is just this is the phenomenon of computing. We are understanding the different levels of abstraction, and we're solving a problem. If you had a higher level abstraction, the problem actually gets a little bit easier. Now, the thing is, have that insight to be able to realize, oh, this problem, we should look at this problem at a higher level abstraction. And hence my question
Yeah.
is like, if at a lower level abstraction, we're talking about 10,000 rules, at a higher level abstraction, we're talking about, well, you're saying 26
Principles or
26
something.
principles, which in a way, there's some sort of a rule here because you're saying identity can be considered by X and Y, and X here can mean name and address, and X can be make, and Y can be model, and so forth. Now, my next question,
another way to think about this is sometimes you go to solve the problem, okay? But a way to get it more abstract is to say, what kind of thing can solve problems like this? Okay, instead of solving that, you're saying that's an example of a class of problems. Can I build something that can solve things like that?
and that again is computer science. You got to want to reduce a problem to something else. This is why this is so fascinating.
By the way, about catalogs, okay? A thing about catalogs, one of the ways I think about what we do and what we do in entity resolution is we have a little database, but it's a special index, but it's like a card catalog at the library. You're not taking all the data from everywhere in the enterprise. You're taking the subject, title, author, like off the library cards, and you're putting it in a card catalog, okay? In that card catalog, you're rubber banding together the cards that relate to the same entity. And now you have a way to get a 360-degree view without having to move all the data. And by the way, how you keep, maps at the library versus DVDs, versus magazines versus books, each of those aisles can have different structures. But at the card catalog is where it all comes together. And I get my inspiration, by the way, did you know that there's a single part of the brain? Like if I said, there's an artist who drives a motorcycle that has passed away not long ago, whose name was a symbol. Okay, you just did entity resolution, okay, to Prince. And in your head, you may have located a picture or the Purple Rain album cover. Your hippocampus did that. The hippocampus is the library card catalog of the brain. And I like to hang out with hippocampus researchers because I get the inspiration for my work on my engine because I'm really building the hippocampus. Ha! Wait, that's a secret.
I love that. That's the cross-functional knowledge going across disciplines, right? Where you get the new aha moments.
Yeah. Like I'm a very curious cat, so when I hang out with people, I track some down, I'm like, can I come hang out with you? If you're a brain researcher and you sit next to me on a flight across the country, you poor thing. Because I want to know about like the details of that, especially that hippocampus.
I have a feeling that would be a very interesting conversation to observe. You mentioned about catalogs and the context. How does metadata tie into entity resolution, and how does that become important? And is it important to do things like catalog your rules and things like that, or catalog your principles, or is that a little unnecessary? Really, what you care about is more the end result of all of that.
Yeah, it's a little bit unnecessary to catalog maybe something that sits in one place and is very short, sits on you could etch it onto a piece of pepper. Small print. But if you think about a bank account that gets opened, because a lot of our customers are like doing transaction monitoring or fraud or sanction screening or something, you wouldn't pass an entity resolution engine all the particulars about the money moving here and there. Those are interesting in rule-based for the rules and alerting. But the one type of metadata would just be what's the name, address, and account on the phone, and what's the identifiers of the entity on the other end. If he said that's the metadata you'd pass to an entity resolution engine, is the features that you need to be able to assemble something and index it. But then, of course, like the library, it has the Dewey Decimal number, it has the pointer back to the actual transaction, the actual account. And where, by the way, this is maybe important just for those, it's not obvious to maybe everybody that might be on listening, is you have data that's your observations that are collected in lots of different piles and different forms. There's video from the parking lot, and there's people onboarding in the loyalty club. But in the other end of the enterprise is, decisioning systems that help focus human attention, driving it to showing a human or a feedback loop to a user or reporting. But in between is where the entity resolution happens. Entity resolution is you're taking your observation space and you're bringing, it's like lots of different puzzle pieces, you're bringing context to it. It's in a form of assembly. It's context construction. And so what comes out of entity resolution is an entity resolved graph. Then you send that to decisioning systems. Good news, bad news, sell it or shoot it. That's downstream from entity resolution.
So I'm still, my mind's still at the principles. When I'm hearing everything you're saying, I'm like, okay, you've observed so many things throughout all your different generations of your entity resolution systems you've built, and you've identified these principles. I'm hearing this. I'm like, okay, there is some sort of what I would call an upper ontology, some sort of semantics that is applicable across so many different domains, where you're representing things as, I mean, high-level abstraction is identities and stuff like that. You have a thing can be identified and so forth, and then you have rules associated to that. Where is this resonate? Is this
well, let me decode a few things. I love this because it's a conversation like this that helps me think about, when I say some words, how do they land? At the front, I'll just use an entity engine, let's say somewhat like ours. You get a JSON message in, it's got a tag on it. This is his name. Here's the name. Maybe there's an AKA, address, label. It's a label, value, label, value, label, value. Okay. Some data sources, the address is a bag of words. Like in a banking Swift message, is a bag of words. It's just a bag. Huh? Other address 1234 or address 12 city state zip. So different sources have different assemblies of those, but ultimately those are tagged as addresses. What an entity engine needs is it just needs to know that's an address and that's a name. And it should just take care of that and do the right thing with it. Okay. Now, but one organization might have some features that weren't conceived of. Like maybe somebody's doing a project in South Asia or in Malaysia. Now they need a Malaysian citizenship ID as a field. Well, they should be able to introduce that. They should be able to introduce a new field, without having to restructure a database and everything, huh?
But then there needs to be, so there's still work that needs to be done about mapping, let's say, the existing metadata of the existing systems to the principles you have. I mean,
not to the principles. You don't map
not to the principles. Well,
no. I'm gonna clear it up really easy.
All right, clear it up.
For every entity, there's a list of features: name, address, phone, cars, make, model, color, whatever.
Yes.
Okay. What you do in a principle-based engine like Senzing is, for each feature, you just tell it we have just three principles. I'll tell you what they are, man. I'll take all the mystery out of this. The number one principle, or I'll call it behavior. It's the way you do principles is you map the features to three behaviors. One of them is frequency. Remember, these are guidelines like Pirates of the Caribbean, okay? Huh? The frequency, so it's not like, what is it? It's like generally, okay? Generally. Frequency is generally when you see this value, does it relate to one entity, a few, or a lot? A date of birth. When you see a date of birth, does that value generally relate to one person, just a few, or a lot? A lot. So you give it frequency many. A home address, frequency few, and if it's your email or cell phone or a social security number, frequency 1. Again, it's just generally. That's one of the behaviors. So jump to vessels, okay? Vessels have what's called an IMO number. It's stamped on the hull, man. It's like a VIN number on a car. Frequency 1. If you see an IMO number, it's probably that vessel. If you find 50 vessels that are all 0000000, then it means that one ain't so good, okay? The second behavior is exclusivity. When you see this feature, do entities tend to have more than one of these or just one of these, okay? A car that has a make or a model. How many makes or models can a car have? Like, have you ever seen a car that's like 2 models? No. So it's exclusive. A social security number person generally has 1, okay? But not a credit card number. So a credit card number is a behavior, is a frequency 1, but not exclusive. But a date of birth, you're only supposed to have 1, other than my bad daddy story, okay? And the third behavior is stability. Over the course of the life of the entity, as it tends to stay the same. You know what? A credit card number doesn't, because somebody steals your credit card number, you got to cancel that little sucker and get another one. Okay, but your social security number does. So a social security number is a frequency 1, exclusive, because you should have 1, and it tends to stay stable. So my rules, call them principles. My principles aren't about the names of the features. It's only about the behaviors. Okay? It just literally, the principles are, hey, man, if things have identifiers but have nothing else that disagrees, okay? And now you can use the same set of principles. I remember I dreamt this up in my head, okay, with this exercise. And my number two, been working with me for years, went off to Singapore to work on a project, started putting vessels in there. I remember the day he called, he goes, you're not going to believe this. We're doing really good matching on vessels and we didn't have to change any rules. I was like, yeah, okay, fine. Don't fire me. Okay, I hope that, you know.
This, I was getting this wrong. I truly thought that you were doing things more kind of and I have a higher level abstraction of the features to kind of some description that of what an identifier could be for multiple entities. But
No,
you're looking at this more from the distribution of the data, right? Like
yeah, that's exactly what it is. And then in real time, I mean real time, thousands of transactions a second, we have a statistics table on the distribution. Not how many times have we seen a date, but how many entities have that date? Not how many times have we seen the phone number, how many entities have that phone number? And that's at absolute real time where we keep those counts, okay, for every feature. And then as it's ingesting, it's using, if you have something that's a frequency 1, but it's behaving like a frequency few or frequency many, it's just self-corrects it. Not just corrects it when it sees it for the future, it goes back in time and goes, oh, well, now I know that. Like a system may, George Foreman named all 5 of his boys George, and one of his daughters Georgetta, okay, or Georgina or something. You don't know that going in. But over time, as you get more data, you discover these, call them glitches in the universe, or where the guideline's not true in this case. And then you want to be able to just change your mind about the past. You don't have to reload.
Interesting. When you talk about these principles, one of the things that I wonder about the state of art of entity resolution is how much can work out of the box, how much needs tailoring to your business or to your own policies and things like that, right? And how much of it is domain specific? Like I need to understand insurance or health or
doesn't matter
naval domains, things like that, right?
Doesn't matter.
How does that spread look?
It's so different now. If you asked me 10 years ago before this latest 6th gen different species that we've been working on, I would say at least 80% of the people that open us out of the box don't have to change a single switch. And I'm talking about voter registration, modernization, to healthcare, this and that, and fraud over here. And, we just had a great project. One of our partners, Code for America, used our engine for a project to the clean slate law in Utah. There's a law, there's certain kinds of felonies. They get rid of those so they're not felons anymore, so they can vote and get access to better jobs. It's a small little entity resolution, probably all run in memory. 80%, man, all just run the same without any tinkering. And if you do need to tinker, see, this was a big lesson, by the way, okay? Back in the day, my 5th generation engine, it would be like this. You would say to me, is it configurable? I'd brag. Here's what I would do. I would open up the cockpit on the 747 or the Dreamliner, whatever and I would show you all the buttons and I'd go, marvel at the configurability. You know what I'm telling you? I'm telling you the manual's 2,000 pages. You need 2,000 hours in the co-pilot seat, okay? And that, you can't commoditize something if something that's complicated. And that's been the state of the union, okay? And the principles piece is a way that generalizes to you can do different missions with different features. Now, we've been specializing in people and company data, but we've had others do, other entity types, but it's it can be a little more work. But anyway, that's the vision, is you shouldn't have to tinker. And if you do need to tinker, I'd be surprised if anybody had to flip more than 5 switches. I mean, maybe if you have to tinker, it's maybe 2. And usually they're sorry. Like later they'll come back and go, wow, we should have just left the default.
I think that's exciting. This is a sign of usability, and it's a sign of, maturation takes an interesting path, right? Where things get more complicated, and then at some point, ideally, they get simpler. And that's cool to see this finally taking and hitting that inflection point.
You know, back like a year ago or two, I'd be like, all you got to do is put it in your mouth and chew. And then I realized people want it easier than that. Now I tell my team, I'm like, I need it to dissolve under their tongue. You hear me? I need it they just put it under their tongue and it dissolves. They don't even need to chew. And that turns out where a lot of the work is now, is just how to make it easier and easy, like less and less work, you know, like on the mapping side. If you have to tell people they've got to parse and figure out the first name from the last name, and it's one bag of words, and now they have to split the name, that's a lot of extra work, you know? So, you know, we have a machine learned algorithm that's been trained on 850 million names. Like, it not only knows, you give it a bag of words, it not only knows first name and last name, it knows an Arabic name. And if it's an Arabic name, it knows bin and haj aren't part of the name. And by the way, if you're going to match a name in a Chinese name versus a name from Ukraine or Russia, you better use an entirely different algorithm, man. So you have to know the culture of the name and then match in the culture. You spend tens of millions doing good name matching. If you want to be a global company, it's crazy.
You know, just before we go to our lightning round here, we, you know, Chat GPT and a lot of the stuff that's going on here. Exciting stuff. Super clever. But also, you know, doesn't necessarily, you know, it's like the smartest, dumbest thing you've ever seen, right? And just curious about, what do you think about that craze, and is there any relationship to entity resolution, you know, now or in the future?
You know, it might not surprise you, but it turns out Chat GPT and things like that are going to need to be able to have counted entities. I've seen 2 people now go ask Chat GPT to give them a bio. It sends them to school in places they've never been. They got a PhD in Oxford, okay? It turns out, but they're going to need entity resolution. They're going to need a resolved entity graph to get to their next level.
So it's not there now, but it needs it.
It's everywhere. When you put entity resolution glasses on and look around, it's in AML, KYC, insider threat, CRM, vendor supply chain, nonprofits.
All right. So
just everywhere.
This is a good segue into our lightning round question, because we got a couple things here lined up here. So all right, let's move to the lightning round, which is presented by data.world. I'll go first. In the next 10 years, will we have democratized entity resolution?
It's done.
Oh, it's done. Not yet. Okay.
It's done. I'm telling you, it's done.
We don't need 10 years?
No.
That's exciting.
I mean, more can be done, but I'm just telling you, that's done. I get people asking me my roadmap. I'm like, you don't even use half the stuff we already do. My Swiss Army knife has got so many things in it. No, done. Next.
That's exciting. Hey, second lightning round question. This actually harkens back to our previous episode where we talked about master data management. Is MDM dead?
No, but it's caused so many bruises and limps and hobbles that it causes a lot of angst when people think that they might have the next $3 million project that goes 2 years and then gets canceled, you know. But, you know, MDM is really about getting your entities better managed, you know. It's a little bit of a falsity to say there's a single version of truth. But being able to properly count your entities and know how they represent each other through your observation space is as essential as ever.
All right, next question. So you mentioned data scientists, they don't build spell checkers. They grab a library. Will entity resolution just become like that, a simple pluggable library?
Done. We literally shoved our $50 million investment to 6th Gen into a DLL or a shared object in Linux where most of our customers do. It's done.
That's incredible. I'm getting very excited now. All right, fourth and final lightning round question. Are we trending toward entity resolution, sort of not the fact that you can have a library, because obviously that makes things very easy, but like the art of entity resolution, are we trending towards it becoming harder as time passes?
The trending will be, there's a lot of really great data scientists that are spending time on something where they could spend their time on something that's actually more interesting and more valuable. For example, the risk scoring models that come after entity resolution, okay, to make higher quality decisions. So the trend's going to be a change of allocation about where you put your smart people. It's not going to be on, I'll call it the mundane task. Who would have thunk that it's so hard to match Beth to Elizabeth? Really? So
the trend is going to be a change where instead of people trying to, I mean, it's going to be a hard problem. And as data gets more complex, et cetera, that's going to continue to make it hard. But if smart people are building great libraries that are democratized, that allow people to do this kind of stuff, then people can spend their time on better, more valuable things.
You know what? It's about outsourcing entropy. It's the second law of thermodynamics. The universe is trying to break itself into little pieces, spread out and cool off. Okay? And we use the food we eat in teams to fight entropy. That's what we're doing. You do not want to have your own team. Do you have somebody at your company writing your own credit card settlement? No, you would use Stripe. You outsource that entropy. Why would we be using your energy to fight that? That's what I'm trying to do in entity resolution. Is we're going to slay your entropy for you.
This has been a phenomenal conversation. All I'm just thinking is, like, I just want to sit. I think Tim and I were just back channeling, like, I just want to sit in the bar and just have a drink with you. And just,
you guys haven't had a single drink.
I started with this glass full. So.
Oh, hey, that was pretty good.
I already wasted all of mine. So
really? How did I miss it? Okay, well, I'm impressed.
And with that, let's see how much we impressed you, because it's takeaway time. So Tim takes us away with takeaways. We've been taking notes while we've been having our drink here about everything we discussed.
All right. Yes. Tim's takeaways. So we started off with, what is entity resolution? And you mentioned it's counting your entities. And don't overthink it. It's really about looking at those entities, counting them. And when we look at all these different things like linking, deduplicating, matching, fuzzy matching, mastering, a lot of these things are actually ultimately talking about the same thing, figuring out how things are related to each other and counting them. And we got into what's the state of entity resolution today. And you really gave us a little history lesson that things have evolved and changed. They've obviously gotten a lot better. You've been at the forefront of a lot of innovation as things have gone from, Gen 1 to Gen 2 to Gen 3 and so on. But the past approach has always been expensive, complicated. The results are iffy. It's hard to do yourself. The biggest companies are spending big dollars trying to solve these problems so that they can move the needle a little bit and get just a little bit better, right? And as you get to larger scales, more real time, you can't do it all in memory. The approach has to change and it gets pretty complicated. Entity resolution, therefore, has been kind of for the elite. And you mentioned, wouldn't it be great if it was free or open or more accessible, and the more common people and companies could take advantage and spend less time trying to solve this problem. And that feels like a really good approach and a good principle here. It gets harder and harder for companies to compete as they get more of this duplicate data, complex data. And the truth is that a lot of bad decisions have been made because we're not counting our entities. Juan, what about you? What were your takeaways?
So several more here. So one, Jeff, you have been seeing this for so long, right? So you have to really see all the use cases to know how to go build something that can work as a general platform, and that's what you've been able to go do. And I love this, like, oh, I got 10,000 rules. It's like, really, is that something you should be proud of? No, right? And interesting here, kind of comment of yours is like, any smart system should learn about the past and make changes based on that past for the future. Like, so that's a very important thing. And how do you integrate the new objects as they go? It's like a puzzle piece, right? Like, oh, I think these two things go together, but another puzzle piece will come in and, like, you'll realize, oh, they don't go together, and so forth. So data doesn't sing unless it's in context. That is a quote I'm going to put on a t-shirt, and I'll give it to you. I love that. And it's all, and this is all imperfect because we live in an imperfect world, right? That we just have to accept that. The principles. I think this, if there is the main takeaway, it's about the principles. Don't throw rocks at cars versus don't throw stuff at other stuff, right? You want to be able to have those principles. And what you've been able to observe over your career is, like, you kind of brought this down to like 26 principles. I really like that they're really behaviors of the data that you're observing here. Talking about the 3 principles: frequency. Generally, when you see this value, does it relate to one entity, a few, or a lot? Second, exclusivity. Does an entity have one of it or many of these things? And stability. Does it tend to stay the same? This is an amazing aha moment for me in actually looking at this as behaviors of the data, right? And in the past, you would have all these configurations. We were very proud of the configurations. Like, go into my cockpit, look at all the knobs you can go to. Now, today, you should not be proud of that. And actually, we should probably offer 2, 5 max. And probably when they'll come back, they should have said, I should have left it in default. We brought up catalogs for a second here. This is catalog and cocktails. And I think entity resolution is like, it needs to have a database like the card catalog, because you want to keep track of all the features here that can provide some extra context. Because remember, data doesn't sing unless it's in context, and the catalog will have that context. And then finally, Chat GPT, it's going to need entity resolution around here. Otherwise, it's a lot of great creative BS. All right, how did we do? What did we miss?
Man, you guys like have summarized my life in just a few minutes.
While I drink the pina colada.
The spark notes of Jeff Jonas.
There we go. All right, so to wrap this up, Jeff, back to you. 3 final questions. What's your advice about data, life? Who should we invite next? And what resources do you follow? People, blogs, conferences, books, so forth.
I'll take that backwards. I like to follow on Twitter. I like to follow Terrible Maps. It's really funny. On conferences, I like the GeoInt conference. And just a thing about both of those is where things are and when and how they move are the highest order bits. If you're trying to do really interesting analytics, geospatial data is superfood for analytics. Okay. So funny side on the maps, and then the GeoInt conference, where people are obsessed with geospatial. Would be two go-tos. Danny Hillis. Oh man, that guy. Do you know Danny Hillis?
So I would love an introduction to Danny Hillis. Danny Hillis, I know him from the Connection Machine back in the 80s during the early expert systems and on parallel computers and stuff. My PhD advisor was Dan Maranker, and at the same time they were doing kind of all these parallel rule engines. And then one of the things I find fascinating about Danny Hillis is just how he's kind of seen the future, right? Jump around afterwards. He founded MetaWeb, which was free-based, which is the foundation of Google's knowledge graph. Like, this is a guy who has seen the future and built it and been there. I would love to have Danny Hillis.
I can make that happen. By the way, do you know about his 10,000-year clock?
I have heard about this, but don't know the details.
That's his invention. This is a clock that runs for 10,000 years without hooking up to any power. It's okay. And then here's a piece of advice I've never shared. Okay, that I can, at least not public, I've shared to a few people. As you go through life, if you're creating a group of people that hate you, that don't like you, in the back halls, they say negative things about you, don't underestimate the weight of that versus creating goodwill. Okay. You want the people that have been through your life on a journey to be in the back room when no one's looking, saying generally good things about you. Okay. And I say that because I've seen 2 cases now where people didn't put care to that. And you know what? It's like having a small army with people. They're just waiting with a ship to stab you. Okay. So anyways, yeah, that's my advice. Makes the future better.
Very profound. I like how we started and we ended here with very profound advice.
Came back to relationships.
Yes. And I'm seeing this comment here on LinkedIn. Takeaway, the final takeaway, just to kind of put the stamp here. Entity resolution is a thing that has been resolved. Would you agree with that?
Yeah. Well, an entity, yeah, probably an entity. It's still a real world entity, to be entity resolution, but whatever. It's making a decision about, you're asserting something, you're asserting something that's true, and then you're willing to change your mind about it if you need to. Proceed with certainty, correct when necessary.
All right, before we say quick goodbye, just a reminder, next week we have Mohammed Said, who's from Capco. We're going to be talking about metadata. Is that really a graph problem or not? And with that, Jeff, this has been a pleasure. This has been a phenomenal conversation. And I can't wait to meet you in person and go sit at a bar and go just chat and just hear all your stories. You are a fascinating individual, and
fascinating,
phenomenal storyteller.
Oh, that was a kind of thing. I prefer nut job. Hey, thanks, guys.
Cheers.
Thanks so much, Jeff. Cheers.
Have a good